integrated rate equation for zero order reaction. In last class, we have derived the integrated rate equation for first order reaction. Now, the integrated rate equation for zero order reaction. To derive this, consider a zero order reaction. Consider a zero order reaction. A tends to P. I mean, A is the reactant, P is the product. The rate of the reaction, how will you express? R is equal minus dA by dt. Already you have got it, how to express the rate of reaction. This is equal dP by dt. This is equal K, concentration of A. This is according to differential rate law. To the power, since it is zero order, so to the power 0. A to the power 0 means 1, you can write K. So this is about the rate expression for this equation. A tends to P. A is the reactant, that's why negative sign. P is the product, that's why plus sign. Now, from the rate equation, you have got minus dA by dt. This is equal K. I mean, this equal this, like that. Or you can write minus dA is equal K into dt cross. After doing this, now integrating both sides of the equation, integration of minus dA, this is equal K integration dt. Integration of dA, this is equal minus A. K integration of dt means T plus 1 integration constant C. Suppose this is equation number 1. When T equals 0, I mean when time 0, what about the concentration of the reactant? Concentration of the reactant is equal to the initial concentration of the reactant, I mean the starting concentration, because you know when time 0, the reaction will not proceed. To proceed the reaction, minimum second time requires. So here time 0 means reaction will not follow. So the concentration of the reactant, you will get the initial concentration of the reactant. Here A0 is initial concentration, I mean starting concentration of the reactant. So if you put time 0, A equal A0, then the equation 1 becomes minus A0 is equal C. I mean you will get the value of C. Now putting the value of C in equation 1, here I will write. Now putting the value of C in equation 1, minus A is equal KT. Now put the value of C equal minus A0, so KT minus A0, or you can write A0 minus A, this is equal K into T, or you can write K is equal, I mean rate constant K is equal concentration of initial concentration minus present concentration divided by time. So this equation is called the integrated rate equation for zero order reaction. You have got the first order reaction integrated equation, K is equal 2.303 by T log of A0 by A. Here the rate constant is not related with log. K is equal A0 minus A divided by T. So like this way, in exam you will get one question, you have to derive the integrated equation either for first order or for zero order, and like this way you can derive the equation. So this equation is called is called integrated rate equation for zero order reaction. Okay, now half-life time of zero order reaction. Half-life time of zero order reaction. Already you know what is half-life time. It is the time required to make the initial concentration of the reactant to its half. That is called half-life time. Suppose initial concentration is 100. As you know, when the time proceeds, concentration going on decreasing. When 100 goes to 50, how much time is required to make it 50? I mean to make it half, how much time is required? That is called half-life time. Already you have done for first order reaction, and in first order reaction you have got the relation like this. T half is equal 0.693 divided by K. Like this way you can find out the half-life time for first order reaction. Now I will find out for zero order reaction. So from the integrated equation you can find out this. We know for zero order reaction K is equal A naught initial concentration minus present concentration of the reactant divided by time. At half-life time, T, what you have to write? T is equal T half. And what about the present concentration of the reactant? You know at half-life time the present concentration will be always half of the initial concentration, I mean A naught by 2. When you put this value in this equation, then K is equal, you can write A naught minus A naught by 2 divided by T half. So this is equal K equal, you can write A naught by 2 divided by T half, or you can write T half is equal A naught divided by twice K. So this is the half-life time for zero order reaction. By using this equation you can find out the half-life time. One of the point of difference between half-life time of zero order and first order, in first order you have got T half is equal 0.693 divided by K. This is for first order and this is for zero order. And look this, here the half-life time is depend on the initial concentration of the reactant, I mean starting concentration of the reactant NO. But here in the first order, the half-life time is independent of the initial concentration of the reactant, and that is the difference between the half-life time of first order and zero order reaction. In zero order reaction, half-life time depend on the initial concentration of the reactant, but in first order reaction, half-life time is independent of the initial concentration of the reactant. So like this way you can derive the integrated equation, the half-life time for zero order reaction and for first order reaction. According to your syllabus, only first order and zero order is required, and you have to do some numerical also for first order and zero order by using this integrated rate equation. Okay, thank you.